All right, this is week 4, Math 208, section 4.3, solving a system of equations using elimination. So first what we're going to do is we're going to do a little bit of review. It says, if possible, use this graph to solve this system of equations, all right? So what we're going to do is first we're going to look at these two lines, and trust me on this, but the red line is the second equation, x plus y is equal to 4. Actually, you don't have to trust me on this. Here's why. Because when we zoom in, if we solve for y, this becomes y is equal to negative x plus 4. And up here, if we solve for y, you end up with y is equal to x plus 0. And so you recall, this is your y-intercept, so it starts at 4, and then this is your slope, and it goes down 1 over 1, down 1 over 1. So this is the red one, without a shadow of a doubt, because you can see it starts at 4 and it's going down. And this one starts at 0 and is going up. So there's our line. And because we can see that they cross right here at 2, 2. So that means that is our solution. X is equal to 2 and y is equal to 2. So that's our solution. But now what they want us to do is they want us to use elimination to prove it. All right? So first off, I'm going to remind you, you can always use Desmos. Remember, go to Desmos. You're going to type in these two equations, and the line will show you, the lines will appear, and then you can zoom in to see where those two lines intersect, if they intersect at all, right? Because they might not. So anyway, now let's take a look at how we solve this problem using what's called the elimination method. So you've got x minus y is equal to 0, and you've got x plus y is equal to 4. So now what you're going to do is you're going to add, we're going to look for opportunities for things to cancel out. And what I mean by that is negative y and positive y, those are opposites. So we're looking for opposites. And because we see opposites, that means we can now add these two rows together. So x plus x gives us 2x. The y's cancel out because negative y plus y, they cancel out. And then 0 plus 4 equals 4. So now we have 2x is equal to 4, so we divide both sides by 2. And that means x is equal to 2. So now that we know that x is equal to 2, you take any one of these two equations, and it doesn't matter which, so I'll take that first one. And you go, okay, x minus y is equal to 0. And now we know that x is equal to 2. So when you see that x, you can replace it with a 2. So it becomes 2 minus y equals 0. So therefore, y has to equal 2 because 2 minus 2 equals 0. So there's your solution right there. X is equal to 2. Y is equal to 2. And so the way you write that down is up here. You say we have one solution, and it's 2, 2. Two ways to do it. One way is you can look at the graph using Desmos. Another way is you can use the elimination method. The previous video, you can use the substitution method. So there are 3 different ways that you can use to figure out where those two lines intersect. All right, it says use the elimination method. Now, first thing I want you to do is I want you to consider going to Desmos and graph these two equations and look to see if those lines intersect at a nice, convenient location. But I'm going to show you the elimination method. So I'm going to rewrite these two equations right here. And I'm going to look for opposites, something that will cancel. And I can see that, again, the y's are opposites. So that means I could just add these two rows together. So I get 2x, because x plus x equals 2x. I see the y's are going to cancel out. And then I got -1 plus 5, that equals 4. So again, I'm going to divide both sides by 2, and I get x equals 2. So now we know that x equals 2. So now we need to choose any one of these two equations, and it doesn't matter which. So let's choose that first one, x plus y equals -1. And I'm going to take that x equaling 2, and I'm going to deposit it right in there. I'm going to substitute it in. So you get 2 plus y equals -1. So you subtract 2 from both sides, you end up with y is equal to -3, and there is your solution to this system of equations. It is 2, -3, and that's where these two lines will intersect. So again, we're going to solve using the elimination method, and I'm going to start by copying the problem down. And this time, however, you'll notice it's the x's that are opposites and that are going to cancel out. So we're going to add these two rows together. And so the x's cancel out, leaving us with 2y is equal to 10. So I'm going to divide both sides by 2, and I end up with y is equal to 5. So now that we know that y is equal to 5, I'm going to take either one of these two equations, and oh, I like the second one, so let's copy that down. X plus y is equal to 4, and now I'm going to substitute 5 where y is. So it becomes x plus 5 equals 4. Subtracting 5 from both sides, we get x is equal to -1, and that is our solution. So we know that these two lines intersect at -1, 5. Of course, I want you to use, always consider using that Desmos, because it will, all you have to do is type in these two equations into Desmos. The lines will automatically appear, and you just zoom in to see where they intersect. And in this case, they intersect right at a convenient integers, a simple location. So you don't really need to do all of this fancy algebra. All right, in this time, we've got x plus 8y is equal to 69. And then we've got -x plus 2y is equal to 11. And I'm going to look for opposites. And sure enough, I see opposites. I see that the x's are opposite. So I'm going to add these two rows together. So the x's cancel. And that leaves us with 10y is equal to 80. So I'm going to divide both sides by 10. And so now I get y is equal to 8. And then, now that I know that y is equal to 8, I choose either one of these two equations. Oh, let's choose the first one. So I'm going to rewrite that. X plus 8y equals 69. And I'm going to take that 8, and I'm going to substitute it into the y. So I get x plus 8 times 8 equals 69. So this is x plus 64 equals 69. And then I'm going to subtract both sides by 64. And that gives me x is equal to 5. And there is our intersection. We see that these two lines intersect at 5, 8. And again, use Desmos, because that would have been much quicker to use Desmos than doing all of this algebra. Now, on this one, I've been saying use Desmos, use Desmos, use Desmos. But the thing about Desmos is it only uses the variables x and y. And here you've got a's and b's. And so that means you have to change it to 4x plus 6b equals -4. In fact, let's do that. Let's just move that down. And then we have the other one, which is -4x plus b equals 18. And we're going to look for opposites. And sure enough, fortunately, we see opposites right here. So we're going to add these two rows together. The 4x's cancel. 4x plus minus 4x, they cancel, leaving us with 7b is equal to 14. Now, oops, really I should have called these y. That should have been, sorry, y. 4x and plus 6y. Stinker, stinker, stinker. All right, so those really should be y's. So if you're going to type this into Desmos, it's got to be 4x plus 6y, and minus 4x plus y equals 18. Okay, so now we're canceling, and here it's 7y. There we go. Now I'm caught up. Divide both sides by 7, and when we divide both sides by 7, you get y is equal to 2. Okay, so now that we know that y is equal to 2, you choose either one of these two equations. I'll choose that first one, 4x plus 6y equals negative 4, and we're going to substitute 2 where we see the y. So you end up with 4x plus 6 times 2 equals negative 4. So that's 4x plus 12 equals negative 4. Now we're going to subtract by 12 on both sides. So that leaves us with 4x is equal to negative 16. And then we're going to divide both sides by 4. And so that leaves us with x equals negative 4. So our solution is x is negative 4 and y is 2. So that's going to be negative 4 comma 2. Now, if we use Desmos, remember you cannot type in the A and the B. You have to replace them alphabetically with X and Y. And then once you've graphed that, the lines will automatically appear, and then you can zoom in to see that they intersect at a really nice, convenient location. No fractions, no decimals, just really nice and easy. Or you could do all this algebra, and you would get the exact same answer. Now this one, if we were to do this in Desmos, you would find out it's not going to work because the answer is not a whole number. It's actually going to be a fraction, which means we actually have to do the algebra. So what we're going to do is we're going to start by copying down the two equations. So you've got 3x plus 5y equals negative 3, and then you've got x plus 5/4 y equals negative 2/3. Now, do we have any opposites? Nope, we don't have any opposites. And so what that means is we need to create opposites. And I see that I have a positive 3x. If I multiply this guy by negative 3x, suddenly I will have opposites. So what I'm going to do is I'm going to bring this guy over, just leave him alone, 3x plus 5y equals negative 3. But then right here, this guy, I'm going to multiply everything, both sides, by negative 3. And what that's going to do is that's going to force us to suddenly have opposites. So when I think of you're going to do it like the distributive property. So negative 3 times x, that gives us negative 3x. There's our opposite, yay. And then we've got negative 3 times positive 5/4. So that's going to be plus a negative 15/4 y equals, and then we've got negative 3 times negative 2/3. You're going to have to trust me on this, but the answer is 2. All right, and now we have opposites. And here are our opposites. So the 3x and the minus 3x are our opposites. So now we're going to add. And we're going to add 5y and negative 15/4 y. So let's ignore the y's for a second. And let's go over here on scratch paper and let's think about that. 5 plus negative 15/4. Well, the way So we're adding these two guys. So the way we do that is we need to have a common denominator. So we're going to think of 5 as 5 over 1. And we need a common denominator of 4. So that becomes 20 over 4 plus negative 15 fourths. So that equals 5 fourths. What a coincidence. Okay, so that equals 5 fourths. So now we're going to go back over here. So when I add the 3x and the minus 3x, I get nothing. When I add the 5y plus the negative 15 fourths y, I get 5 fourths y equals, and then I get a negative 1 because negative 3 plus 2 is negative 1. So now I want to get the y all by itself, so I'm going to multiply both sides by 4/5, and I end up with all this cancels out, leaving us with just y, and the right side ends up being negative 4/5. There's our fraction. See, Desmos doesn't do fractions real well like that. So now that we know that y is negative 4/5, we're going to choose any one of these two equations. Oh, let's choose this first one. And I'm going to write it down again. Plus 5y equals negative 3. And I'm going to replace the y with negative 4/5. So now we end up with 3x plus, and then it's going to be 5. I'm just going to put 5 over 1 times negative 4/5 equals negative 3. So that's the y. We replaced it with the negative 4/5. And so we end up with 3x plus, and then what's this? Well, the 5's cancel, and so that leaves us with negative 4 equals negative 3. So I want you to think of this as 3x minus 4 equals negative 3. And now how will we solve this algebraic equation? Well, you add 4 to both sides. You end up with 3x equals 1. And then you divide both sides by 3, and you end up with x is equal to 1/3. So now we have our two coordinates. We have x is equal to 1/3. Let's see, I'm going to write it over here. We have x is equal to 1/3, and we have y is equal to negative 4/5. Now where did I get that? It's right there. So there is our intersection. So if we wanted to know where these two lines intersected, they would intersect right here. Whoa, undo. I don't know where that came from. Oh, right there. Oh, right there. Good. They would intersect at 1/3, comma, negative 4/5. And in this case, Desmos wouldn't help you a whole heck of a lot. It would really have to be something that you have to do algebraically. So on this one, it is a great example of opportunity to use Desmos. And the thing is, you have to remember, you can't use the variables u and v. You would have to turn them into x's and y's. So that would be 5x plus 3y equals negative 16. And then this one would become 2x plus y equals negative 5. So you got those equations, you put them into Desmos, and you're going to find out that the answer is actually nice, beautiful whole numbers. It's really easy. You don't even have to do any of the work. But let's do the algebra because, you know, we kind of have to. So let's do it. So there it is. Do we see any opposites? Nope, we don't see any opposites. But we can create opposites by multiplying this second equation by negative 3, because that would make the y's opposites. So I'm going to multiply this equation by negative 3. And the first line, I'm going to leave it alone. So that becomes 5x plus 3y equals negative 16. And then this line becomes negative 6x minus 3y equals positive 15. So everything got multiplied by negative 3. And now you can see we have opposites. So we can add, because our positive 3y and negative 3y, they cancel each other out. That gives us negative 1x equals negative 1. You divide both sides by negative 1. You end up with x is equal to positive 1. There you go. So now that we know that x is equal to positive 1, you choose any one of these two lines, and it doesn't matter which. So let's choose the simple looking one. So that's 2x plus y equals negative 5. And then we know that wherever you see an x, you replace it with a 1. And so that becomes 2 times 1 plus y equals negative 5. So that's 2 plus y equals negative 5. Subtract 2 from both sides. So you end up with y is equal to negative 7. And so that tells us that our intersection between those two lines is 1 comma negative 7. And so if you were to graph that using Desmos, that's exactly what you would see. You would see these two lines, and their intersection would be at 1 negative 7. Now, it still says use the elimination method, but I'm going to tell you, use Desmos, because if the answer is a whole number, you might as well just use Desmos and then you're done. But because it might not be a whole number, I don't know, I'm going to show you how to do the algebraic method anyway. So we've got 4x, let's get this going. I'm going to copy those two equations down. 4x minus y equals 24. And then I've got x plus 2y equals 15. And right now, do we have any opposites? No. But one way to make an opposite is we already have opposite signs. So to make an opposite, we could take this first equation and multiply by 2, because that would give us opposites in the y's. So that becomes 8x minus 2y equals 48. And then this equation, we just bring it over. So that becomes x plus 2y equals 15. And now you see we have our opposites. So we are now officially ready to add our lines together. And that gives us 9x equals 63. So now I'm going to divide both by 9. And that gives me x is equal to 7. So now we know that x is equal to 7. So we're going to choose either one of these two equations, and I'm going to choose this one because it looks like it's the simplest. And let's just write x plus 2y equals 15, and we know we're going to replace that x with a 7. So that becomes 7 plus 2y equals 15. Subtract both sides by 7. That gives us 2y is equal to 8. Divide both sides by 2. So y is equal to 4, and there is our ordered pair. So our answer is 7 comma 4. Now if you use Desmos, that would be much faster, and that would give us the exact same answer, and you wouldn't have to do all of this algebra. All right, so again, we are doing the elimination method, and again, heads up, please try and use Desmos first, because Desmos might give you the answer straight up without having to do any algebra whatsoever. So, but I'm going to show you the algebra anyway. So we got negative, so there's our first one, 2x minus 3y is equal to negative 8, and then we have 7x plus 2y equals 22. And do we have opposites? Nope. But we do have opposite signs right here. So that's the start. So what I'm going to do is kind of a little trick. I've got a 3. I'm going to multiply it by 2 because that's going to give us 6. I'm going to multiply by 2. And down here, we have the 2, but I want the 3, so I'm going to multiply it by 3, and that's also going to give us the 6. So what ends up happening is this first line becomes 4x minus 6y equals negative 16. And this second line becomes 21x plus 6y equals 66. And rockin', there is our negatives, our opposites. So if we add these two lines together, I get 25x, the y's cancel out, and then we get equals 50, and that's an easy one. X is equal to 2. And now that we know that x is equal to 2, you go back to either one of these original equations, and let's choose that first one because it looks like it's the smallest. It's the easiest. And you replace the x with a 2. So that becomes 2 times 2 minus 3y equals negative 8. 4 minus 3y equals negative 8. You're going to subtract by 4. So that ends up being negative 3y equals negative 12. Divide by negative 3. And so you end up with y is equal to 4. And there is our ordered pair. Our ordered pair is going to be 2, 4. Now on this one, since these are nice, beautiful, simple little whole numbers, it would have been way quicker to use Desmos because that would have given us the answer without having to do any algebra whatsoever. All right, last one. Again, heads up, use Desmos. But I'm going to quickly do the algebra. So I'm going to begin by copying the two equations. And then the next one is 4x plus 3y equals negative 2. Rockin', we already have opposites right here. So that means if we add, you end up with 2x is equal to 1. And so you divide both sides by 2. You get x is equal to 1/2. All right? So now you just take either one of these equations, and I'm going to choose the second one. So I'm going to rewrite that. 4x plus 3y equals negative 2. And I'm going to insert 1/2 where the x is. So that becomes 4 times 1/2 plus 3y equals negative 2. And remember, that's like 4 over 1. So the 2 and the 4 cancel. And you end up with 2 plus 3y equals negative 2. And then subtract by 2 from both sides. You end up with 3y equals negative 4. Divide both sides by 3. And you end up with y is equal to negative 4/3. And there are our two coordinate pairs. So you get 1/2 comma negative 4/3. And there is our answer. Now this one, Desmos would not help you with it because it's fractions. And Desmos doesn't play nice with fractions. So this one is a problem that you have to use the algebra method.